In this session, I will discuss about the introduction to discrete probability distribution. First of all, we will look about what is a probability distribution. A probability distribution identifies either the probability of each value of an unidentified random variable when the variable is discrete, or the probability of the value falling within a particular interval when the variable is continuous. If I explain about this furthermore, it simply says about if you are having a random variable as x, then for such a variable, if you are considering discrete values for x, then the probability values assigned with those values can be considered as a probability distribution. Since your variable is a discrete, then you will have a discrete probability distribution. And here, as the random variable, you are having a continuous random variable. Therefore, you are having interval of value as your random variable. Therefore, probability of being including in that interval will be tabulated. Then you can easily get a continuous probability distribution. Therefore, since your variable is a continuous one, then you will get a continuous probability distribution. Therefore, in other words, if you describe this, then you can say like this: the probability distribution describes the range of possible values that a random variable can attain, and the probability that the value of the random variable is within any measurable subset of that range. Therefore, if you focus about the discrete probability distributions, these can be identified as the most common discrete probability distributions. 1. Binomial distribution. 2. Negative binomial distribution. 3. Geometric distribution. 4. Poisson distribution. If you go through these four distributions in briefly, first I will look about binomial distribution. The binomial distribution gives the probability of exactly n successes in n successive trials. Therefore, if you are having n number of successive trials, then here you can count the how many successes were there. Therefore, the successes were denoted by the number, the notation x. And if you briefly go through the negative binomial distribution, negative binomial distribution gives the probability that it will take exactly n successive trials to produce exactly x number of successes. Therefore, if you compare the binomial distribution with negative binomial, in the binomial distribution, we are having n number of trials, and among this n number of trials, we are counting how many successes were there, and we are denoted it by x. But in the negative binomial distribution, we are doing it as until we are getting x number of successes, we are counting how many trials we need. Then if you move to the geometric distribution gives the probability that it will take exactly n successive trials to produce the first success. Therefore, here we can have like this: until we are getting the first success, we can count how many trials should be there, and the trials are denoted by this number n. And the last one, Poisson distribution. Poisson distribution gives the probability of exactly n successes over some continuous interval. This interval can be time or space or volume. Therefore, these are the four commonly using discrete probability distribution. Therefore, thank you all for joining with this session.